Let's start with chapter number 3, Metals and Nonmetals. So I would be talking about first difference between metals and nonmetals, and I would be noting you down some important points from NCERT. So you can keep your NCERT with you, and let's start this chapter, Metals and Nonmetals. So as you know, some metals I would name like iron, copper, aluminium, magnesium, lead, zinc, sodium. These all are metals that are easily available. So we would be talking about them in various activity. So we would be talking about physical properties of metals. So first of all, written in this book is metals in their pure state have a shining surface. So you can mark this part, and this shining part of it is known as metallic luster. Therefore, there is a property named as metallic, or you can say lustrous. So another property name is lustrous for metallic luster. So mark this point in your NCERT. Now moving on to next. So it says you will find that metals are generally hard. That means the metals are hard in structure. The hardness varies from metal to metal. Like different metals have different hardness. Their hardness varies from one metal to another. Now, in activity 3.3, they says that take a piece of iron, zinc, lead and copper and put one metal on a block of iron and strike it 4 or 5 times with a hammer. So you have to keep four different metals, and you have to like strike it with a hammer. And what do you observe in it? Like all these metals will change their shape accordingly. Like iron can have a different shape, lead can have a different shape, zinc can have a different shape, copper can have a different shape. So that means that depend on the metal characteristics. Now the third is metals can be beaten into thin sheets, and this property of metals are known as malleability. So mark this point. Next is the ability of metals to be drawn into thin wires is called ductility. The ductility is the fourth one. Ductility means that the those metals which can be drawn into thin wires are known as ductility. Now, mark this point. This is very important. It can come under MCQ. So it is gold is the most ductile metal. So remember this or mark this point as a very important part of it. Now, it is because of their malleability and ductility that metals can be given different shapes according to our needs. Like we can have a shape of utensils, we can have a shape of a ring, we can have a shape of a like gold chain, many things it could be. So we can make it according to our needs. So can you name some metals that are used for making cooking vessels? We have aluminium. So do you know why these metals are used for making vessels? Yeah, because they are good conductor of electricity, and it could be good conductor of electricity, and they are less reactive to food items because they form metal oxides. That's why. Now, as you can see in figure 3.1, it shows how metals are why metals actually are good conductor of heat. So as you can see that they are heating this metal wire at one end, and there is a pin which is attached with the help of wax. Now this metal wire get heated up and the electrons would transfer till here, and this portion will also get heated. This is due to This shows actually that they are good conductor of electricity. They can conduct, sorry, not electricity, it is heat. They can conduct heat very easily, and this pin will get down because this wax will get melted up. Now, mark the points given here. It says that metals are good conductors of heat. This is the fifth property of it, and they have high melting point. The best conductor of heat are silver and copper. Lead and mercury are comparatively poor conductors of heat. Do metals also conduct electricity? Yes, metals do conduct electricity. They are good conductor of electricity. Let's see how. So in activity 3.6, you can see that they are having a circuit in which they have given a space of clips from A and B where you can insert a sample to be tested. Like you can take any metallic thing and keep here, and this circuit then will be a closed circuit. Then there would be some conduction of electricity here. That represents that metal can conduct electricity. And suppose if we take the first one we take is key, and the second one we take a wood piece. So in the case of key, as you know, key is made up of metal, then it can conduct electricity and this bulb will glow. But if we take wood in it, then bulb will not glow. Why? Because they are bad conductor of electricity. Now in this we have very important question. It says that, as you know, that electric wires coated with such substances, they are coated with PVC. Why they are coated with PVC is because they are bad conductor of electricity. So that's why they make a covering of PVC or a rubber-like material so that one does not get current. Now the second question it asks is what happens when metal strikes a hard substance? So it creates sound, and this property of metal is known as sonorous. So metals that produce a sound on striking a hard surface are said to be sonorous, like in the school bells. So this is about metals. So non-metals are either solid or gases except bromine, which is a liquid. So please mark this point in which it says that bromine is only liquid in non-metals. Either we have non-metal as solid or gases, like we have sulfur, iodine, we have carbon, we have oxygen, we have uh, oxygen, then we have nitrogen. So many compounds are there under non-metals. Then, as you know, they are actually opposite of metals. So they are not hard. They don't have any malleability. They do not have any ductility. Then they do not conduct heat and electricity. They do not have any sound. That means they are not non-sonorous. Now we would be having some exceptions in it, like the first one. It says all metals except mercury exist as a solid at room temperature. So only one is exist as a solid at room temperature, exist as a liquid at room temperature. Then we have, as you know, that metals have very high melting point, but gallium and cesium have a very low melting point. If you keep these two metals in your hand, they will get melted. They have such a low melting point. The second is iodine. Iodine comes under non-metal, and but it is actually lustrous. Third one is a carbon. Carbon is a non-metal. Non-metal, being non-metal, it has actually allotropes. Two types of allotropes are there, that is diamond and graphite. So diamond has a very high melting point. Being a non-metal, it has very high melting and boiling point. Whereas the graphite is another allotrope of carbon and has a very good conductivity towards electricity. So that's some exception we have under metals and non-metals. The fourth one is for alkali metals. Alkali metals such as lithium, sodium, potassium, they are so soft that they can be cut with a knife. So remember these four names, four different types we have under metals and non-metals. Now let's move on. Now we need to talk about chemical properties of metals, how they react with different elements to form new things. So the first one is what happens when metals are burnt in air. That means we need metal, we need oxygen, then there would be a product of it. So now, as you know, most metals actually combine with oxygen to form metal oxides. So when we have metal, in the presence of oxygen, they form metal oxide. So mark this point under this. So this is the general equation. When metal reacts with oxygen, they form metal oxide. Now we have some examples under it. The first one is of copper and aluminium. So as you can see, copper when reacts with oxygen form copper oxide, and remember it gets converted into a black color. That means copper oxide is of a black color. This comes in examination for 1 marks. Now the second one is aluminium. Aluminium forms aluminium oxide. Now in this a very important point is there on this page, that is amphoteric oxides. So amphoteric oxides are those oxides which can react with acids as well as bases. So they can react with acids as well as bases. So please mark this point. Now, as you can see, they have shown you two different examples for it. Like aluminium oxide is actually an amphoteric oxide. Why? Because it can react with acid as well as with base. Now you can see amphoteric oxide is there, acid is there, that is HCl, hydrochloric acid. When reacts with it, it forms aluminium chloride and water. In the second one, you can see again aluminium oxide is there, which is amphoteric oxide. When reacts with base, when react with base forms sodium aluminate, that is, and water is formed. Now, so I hope this is clear. Amphoteric oxide, those oxides which react with both acids as well as bases to produce salts and water. Now, most of the metal oxides apart from this are insoluble in water, but some of these dissolve in water to form alkalis. Now remember, alkalis are those which actually gets dissolved into water. So that's the difference between base and alkalis. Base never get dissolved in water, whereas alkalis gets dissolved in water. So remember this. Now this is, you can see here, we have a metal oxide reacting with water to form base, and in this case again, when metal oxide reacts with water, it forms base, or you can say alkalis. Alkalis are those which can actually dissolve in water. Now the second important thing in this paragraph is, as you know, we have some metals such as potassium, sodium. They react so vigorously that they catch fire if kept in the open. So if you want to protect them, or you want to have some prevention for accidental fires, so you must keep them in kerosene oil. So please mark this point. This is very important. Now, at ordinary temperature, the surfaces of metals such as magnesium, aluminium, zinc, lead are covered with a thin layer of oxide. So this protective oxide layer prevents the metal from further oxidation. So this is very important. Like, they ask some question related to this, like why we use aluminium for utensils. We use aluminium for utensils because when we heat it for first time, the first layer is of aluminium oxide, and that aluminium oxide helps us to prevention for next thing. Like, if you make a new thing on that utensil again, it won't react with aluminium anymore because it is aluminium oxide. So that's the reason we use it. And let's start with the next one. Second is what happens when metals react with water. So let's see what happens when metals react with water. This is the experimental apparatus for when metals react with water. So as you can see in the diagram, metal is there, then they have a glass full soaked in water, and we have a burner here. Why burner here? Because when you heat the glass full soaked in water, it will release some water vapors and they will go towards metal sample and it will react to metal. Now, metal and water when reacts form metal oxide plus hydrogen. Now, the metal oxide, if reacted with water again, it will form metal hydroxide. So, this is very important. In case of metals such as potassium and sodium, as you can see, they react violently with cold water and forms a base. These two are base. Then hydrogen gas is released and heat energy is released. So this type of reaction is known as exothermic reaction that involves hydrogen gas and it can easily catch fire. Now the next one is for calcium. Calcium is actually very less violent. The heat evolved in this case is not sufficient for the hydrogen to catch fire. Now, if I talk about calcium, calcium in this case starts floating because the bubbles of hydrogen gas formed stick to the surface of metal here. Like suppose we have a calcium here in the metal sample box. So in this, suppose we have a calcium, and when calcium reacts with water, it sticks to the surface of the calcium itself. Therefore, very less amount of hydrogen gases evolve here. Now, in the case of magnesium, magnesium never reacts with cold water. It reacts with hot water. So remember, magnesium reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to the surface of the metal only. Now we have aluminium, we have iron and zinc. They do not react with cold water or hot water, they react with steam. So we have different types of metals and they react differently with steam. Some react with steam, some react with cold water and some react with hot water. And some metals are there that do not react. They are least reactive metals as well. Lead, copper, silver and gold do not react with water at all. So mark this point as well. Now moving on, the third part of it, it says what happens when metals react with acid. So metal when react with acid form salt, and another thing is hydrogen gases evolved. Now in this case they have said write an equation for the reaction of magnesium, aluminium, zinc and iron with dilute hydrochloric acid. So suppose we have magnesium and we have HCl. So when they react, they will form magnesium chloride and H2 gas is released. As we have reacted with HCl, we can always take any other compound which is acid. So let us suppose if we take HNO3. Now HNO3 being a strong oxidizing agent, it can actually oxidizes the H2 produced in water. Therefore, we don't have hydrogen gas when we react metal with HNO3. So it forms either N2O, NO and NO2, that is nitrogen oxide and nitrogen monoxide. And but if we have magnesium and manganese, when react with HNO3, they do evolve H2 gas. So remember this. Now, as we have magnesium, aluminium, zinc and Fe. Fe is iron. So this is the reactivity decreasing in decreasing order. So rate of formation of bubble was the fastest in case of magnesium because being the most reactive one, it will have quick reaction, whereas as compared to iron will have very less reactivity, or you can say no bubbles will be there. But if we take copper, as you know that the copper are the most least reactive. Least reactive means that they won't react with HCl. There won't be any formation of bubbles there. So this is about how metals react with acid. They form salt and hydrogen gas, but there is some exception to it. Now we have some important point in do you know, it is aqua regia. So aqua regia is actually a freshly prepared mixture of concentrated HCl, remember HCl, and concentrated nitric acid, and it is in the ratio of 3:1. That means 3 part of hydrochloric acid is being added and concentrated nitric acid is of 1 part. That means 75% of HCl will be added and concentrated nitric acid will be 25%. It can actually dissolve gold in it even though neither of these acids can do so alone. Like suppose if we have a beaker, in it we have hydrochloric acid. It cannot dissolve gold alone. It should have nitric acid in it. Only nitric acid and mixture of nitric acid and HCl can dissolve gold in it. So aqua regia is a very corrosive and a fuming liquid. It is one of the few reagents that is able to dissolve gold, and so I will cover the next part of it in next video. So stay tuned with us and keep watching our videos. Thank you for watching this video. Have a great day ahead.